Okay, welcome back. So in the videos so far, what we've done is to define the fully permissionless and the dynamically available settings, and we've seen various results for those settings. And what we want to do next is to go on to define the quasi-permissionless setting. Okay. So first of all, let's just briefly remind ourselves of the dynamically available setting. So in the dynamically available setting, we suppose that if TR is the set of transactions confirmed for some honest player P at time T, then at least one honest player allocated non-zero stake by that set of transactions is active at that time slot. Okay, so basically if you look at the set of confirmed transactions, look at who's owned a stake according to that set of confirmed transactions, then at least some honest, one of those players who's honest must be active and sort of carrying out the protocol. Okay, so that's the dynamic available setting. We now want to move on to consider the quasi-permissionless setting. What we're going to do first of all, though, is to define the quasi-permissionless setting just for stake. Okay, because if it's just for stake, it's very simple. So here's the version just for stake, and then we'll generalize to arbitrary on-chain resources in a little bit. Okay, so let's state the version just for stake then. So in the quasi-permissionless setting, we suppose that if TR is a set of transactions confirmed for some honest player P at time T, then all honest players allocated non-zero stake by that set of transactions are active at that time slot T. Okay, so previously in the dynamic available setting, we know that at least one honest player from that set is active, and now we can assume that they all are. Okay. So the basic fundamental difference here is that this is what allows us to carry out sort of the classical BFT quorums type protocols. Right? If you're doing a classical sort of BFT type protocol, we generally use quorums or quorum certificates that require signatures from 2/3 of the stake or something like that. Okay, and generally that's not going to be possible. You're not going to get quorums of that type unless the honest players are actually active and participating in the protocol. Right? If only a tenth of the players or a tenth of the stake is actually turning up and participating, you'll never get this quorum. Okay, so it's the quasi-permissionless setting that allows us to carry out sort of classical BFT style protocols. Okay, so hopefully you agree that's very simple. Right? That's the version just for stake. So now let's think about how to generalize that a little bit. Yeah, so as I've mentioned several times in the previous videos, a stake is the canonical on-chain resource, but there are other types of on-chain resources. Okay, so I want to show you some examples of that next. So there are various proof of work protocols: Hybrid, Solidar, and Bitcoin. They're all slightly different from each other, obviously, but at a high level, they all operate in a fairly similar sort of way, which I want to sort of summarize now. So basically, the idea is as follows: a proof of work is used to select a rolling sequence of committees. Okay, once a committee is selected, okay, they then just carry out a classical BFT style permission protocol to implement the next consensus decision. Okay, we've just got a fixed set of participants there, the committee, right? They can then just carry out a classical permission protocol amongst themselves. Right, they do that in order to implement the next consensus decision. And what does that mean? Well, that next consensus decision includes the next sequence of transactions to be committed to the blockchain, right? As well as determining which players have provided sufficient proof of work in the meantime for inclusion in the next committee. Okay, so this particular committee determines the next sequence of transactions to be included in the blockchain, and also who's the next committee. Then obviously once you've got the next committee, you can just iterate this process, right? So that next committee then carries out the BFT style permission protocol to determine the next sequence of transactions and the next committee, and so on. Okay, so hopefully the basic idea is clear. So in that context, right, the on-chain record that P is a member of the present committee, that should be seen as an on-chain resource. Right? That resource allows P to participate in the consensus protocol, can potentially earn rewards and be transferable. Okay, now also, so these protocols operate in some version then of the quasi-permissionless setting that we define for stake. Basically, all honest players with on-chain resources are required to be active, otherwise the protocol will stall. And once you've got a committee, once you're registered having this on-chain resource, we require all the honest members of that committee to be active in carrying out the protocol, otherwise you might not have liveness. Like a typical BFT style protocol would stall otherwise. Okay. So we want to define a more general version of the quasi-permissionless setting that allows us to talk about more forms of on-chain resource other than stake. So let's go ahead and do that. So first of all, let's just sort of generalize the definition of an on-chain resource. Okay, so we'll do that first of all by talking about protocol-defined resources. Okay, so a protocol-defined resource is just a very simple thing. It's just a function, S star, let's say, that takes a set of messages and allocates each identifier some resource balance. Okay, so for any given set of messages and any identifier, this is just gives you some natural number output. Okay, so it's just like a sort of a very general version of a stake allocation function, if you like. Okay, so that's protocol-defined resources. And then by the on-chain resource, I mean a resource is either stake or protocol-defined. Okay, so far so simple. So for now, I'm just writing down this very simple definition. As we'll talk about in a little bit, there are some sort of nuances that come up, and so we'll come back to this. Right? Okay, first of all though, so here's just the general definition of the quasi-permissionless setting. So with the quasi-permissionless setting, protocols are allowed to specify a set of on-chain resources, S1 star to SK star. Okay, so each of those could be protocol defined or could be stake. And then by definition, an execution of the protocol is consistent with the quasi-permissionless setting if honest players are active whenever they own on-chain resources. Okay, so it's just a simple generalization of the version for stake. Okay, so there are some nuances here though, right? That means we do want to refine the definition in certain ways that we'll come to. Okay, so what do I mean by that? Well, because the definition of protocol-defined resources is so general, okay, so generalizing the simplified quasi-permissionless setting, not just for stake, to arbitrary such resources, can lead to the consideration of essentially permissioned protocols. Okay, so let's see what I mean by that. Okay, so for example, but previously we considered this sort of generic proof-of-work BFT style protocol, right, where we had these rolling sequences of committees. Okay, so we considered these protocols like hybrid, Solida, Bitcoin. Okay, where you have proof-of-work is used to select a committee. That committee then carries out a BFT style protocol in order to execute the next consensus decision. That consensus decision determines the next sequence of transactions to be included in the blockchain, as well as the next committee and so on. Okay, so in that case, okay, it didn't seem that permission, right? Because we had this rolling sequence of committees. According to the definitions we've laid down so far, though, there's nothing about the quasi-permissionless setting that forces the change in committees, right, for general on-chain resources other than stake. For stake, it's not true, because liveness forces us to finalize transactions issued by the environment that transfer stake. So stake will necessarily be transferable, right? Okay, but if we're talking about sort of general on-chain resources, that's not yet the case. So a different version of this sort of just generic proof-of-work BFT style protocol might refuse to transfer on-chain resources and just have a single committee carry out state machine replication. Okay, there's nothing stopping it doing that so far, according to the definitions we've laid down so far. Okay, now the question is, can you call such a protocol permissionless or quasi-permissionless with a straight face? And basically, I think the answer is no. Okay, so that leads us then to the notion of reactive resources, and we'll cover those in the next video. Okay, so I'll see you there.